Hello everyone, this is Vijetha, Associate Professor from the Department of ECE, MLR Institute of Technology. In this video, I would like to talk on Introduction to Verilog from the subject Linear and Digital Integrated Circuit. Here, these are the topics which I need to cover, which I want to cover in this lecture. What is concurrency? What is simulation and synthesis? What are the functional verifications and system tasks? What is program language interface modules? And what are the simulation and synthesis tools which are used in Verilog? First, concurrency. In an electronic circuits, all the units ought to be active and functionally concurrently. The voltages and current in different elements in a circuit can change simultaneously. In turn, the logic levels too can change. Simulation of such circuits in HDL calls for concurrency of operation. A number of activities may be spread over a different modules or to be run concurrently. Verilog simulators are built to simulate concurrently. Concurrency is achieved by proceeding with the simulation in equal time steps. The time steps is kept small enough to neglect compared with the propagation delay values. So all the Verilog codes or the code which we have written in Verilog code are going to be executed with the equal intervals of time, which is said to be as a concurrency. All activities scheduled at one time steps are completed. Then the simulator advances to the next time step and so on. The time step values refer to a simulation time, not a real time. One can redefine the time scale to suit technology as when necessary or carry out test runs. In some cases, the circuit itself may demand sequential operations as with data transfer and memory-based operations. Only in such cases, sequential operations is ensured by a appropriate usage of sequential constructs from the Verilog HDL. The next one is simulation and synthesis. The design that is specified and entered is simulated for functionality and fully debugged. The translation of debugged design into the corresponding hardware circuit is called as a synthesis. The tools available for synthesis relate more easily with the gate level and data flow level. The circuit realized from them are essential direct translation of functions into circuit elements. Many of the behavioral level constructs are not directly synthesizable. Even if synthesized, they are likely to yield relatively redundant or wrong hardware. The way out is to take a behavioral level module and redo each of them at a lower level. The process is carried out successively with each of the behavioral level module until practically the full design is available as a pack of module at gate and data flow levels, which is called as a RTL level. Next one, functional verification. Testing is essential ingredient in VLSI process with any hardware circuit. It has a two dimensions, the functional test and timing test. Both can be carried out in a Verilog. Timing or functional verification is carried out by a functional testing and functional verification is carried out by setting up with a test bench for design. The test bench will have a design initiated in it. It will generate the necessary test signals and apply them to the initiated design. The output from the design are brought back to a test bench for further analysis. So each and every Verilog code can be tested by using a test bench code. Where in test bench code, the necessary test signals can be applied directly to a initiated design, and further can be analyzed with multiple inputs, and you can check the multiple outputs for multiple inputs. The input signal combinations, waveforms and sequence required for testing all to be decided in advance and the test bench configured based on the same. The test is mostly done at a behavioral level. The constructs, these are flexible enough to allow all types of signals to be generated. In this process of testing a module, one may have to access variables hidden inside other modules initiated within the master module. Such variable can be accessed through a suitable hierarchical addressing. The next one is PLI, that is Programming Language Interface Module. PLI provides an active interface to compile Verilog module. The interface adds a new dimensions to working a Verilog route from the C platform. The key function of interfaces are as module. One can read data from the file, pass it to a Verilog module as an input. Such data can be test vectors or other input data to a module. Similarly, variables in Verilog module can be accessed their values written to an output device. Delay values, logical values within a module can be accessed and altered. Blocks written in C can be linked to a Verilog module. These are the three key functions which helps to interface the HDL. Any Verilog program begins with a keyword called a module. Module is a name given to a system. Consider it as a black box with input and output terminals. With inputs and output terminals. Module is a block name which is also called as a black box with inputs and outputs, which can be defined with inputs and outputs. The terminals of modules are referred as a ports. Inputs ports and output ports. The ports attached to a module can be of three types. Input ports. The first one is input ports, through which one can enter into a module. This signifies. First one is input port, through which one gets entered into a module. This signifies the input terminals of the module, which can only helps to transmit the data into a module. The second one is output port, through which one can exit the module. This signifies the output signal terminal of the module. This signifies the output signal of the module. If you can see, the second one is output port, through which one exit the module. This signifies the output signal terminals of the module. This shows the input port which is entering to a module, and this shows the output port which is exiting from the exits from the module, and one more port which can be called as a in-out port. This port represents through which one gets enter into a module or exit the module. These are terminals through which signals are input to the module sometimes. At sometimes, these signals are output from the module through this. That means this can be either used as an input port or you can use this as an output port. This is a module, and this module name has been given with the keyword module. Adder is a box name, that is module name is an adder which is given with the specified inputs and outputs. Module is a keyword which is used to define the keyword, which is used to define the operation, and adder is the name of the module, and in this braces it gives the inputs and outputs which has to be terminated with the semicolon. Structure of a typical simulation module. So, your Verilog code first starts with the keyword called module, gives with the module name, then you can write n number of statements, and this module has to be end with the keyword called end module. This module signifies the declaration of module, and the test represents the name assigned to a module, and this semicolon signifies the termination of the module statement, and these statements gives the statements gives the operation, that is the program which you can write, that is the code which you can write, which has to be terminated with a semicolon, which specifies the termination, and it has to be end with the keyword called end module, which signifies the termination of module. An example, 8-bit 8 input NAND gate, 8-bit input NAND gate. This is a NAND gate which is having inputs of I1 to I8 and output O. So here module which signifies the declaration of module. NAND gate represents the name of the module, and this O represents the output of your module, and I1 to I8 represents the input of the module. So now this is a block which is having an output O, which is having an inputs from I1 to I8, and this block name is given with a NAND underscore gate. And these are the individual statements which can be written and end with the semicolon. And like I can write, and NAND can be available as a primitive. NAND, comma, O output, comma, inputs I1, I2 till I8, end with the semicolon. So it performs an AND operation with this, and the output is stored in a AND gate. After writing a code, this module has to be end with the keyword called end module, which specifies the termination of the module. Simulation and synthesis tools. A variety of software tools related to VLSI design is available. We discuss here two of them directly relevant to us. One is Model Sim. The next one is Leonardo Spectrum of Mentor Graphics. Model Sim have been used to simulate the design. Leonardo Spectrum has been used to obtain the synthesized circuits. Here, in this video, we determine what is the difference between synthesis and simulation, and what are the functional tests and timing tests. And next, module structure have been defined. And we also done with the concurrency. What is concurrency? And we are using Verilog is using a concurrency. So these are the topics which I have covered in this video. Thank you.